So, hello everyone, welcome to the second part of this new chapter that we're doing, which is about scheduling. From what we did for the previous video, we did the introduction part. What is scheduling? How is it applied in the company? And we say that as far as the calculation are concerned, we have three main methods to assign the job. They call it load, job loading. I think. Yeah, so what is happening is more about us allocating the jobs to different workstation and so on, and sequencing jobs also. So we said that there are three methods that we will use in this chapter. The first one is going to be about the job assignment. The second one, the assignment method. The second one is going to be the priority rule, whereby we have the first come first serve, the earliest due date, the latest processing time, the shortest processing time, and finally the earliest due date, if I'm not mistaken. Yeah, so, and the last part is going to be about the Johnson rules. So in this video, one thing that we will be doing the assignment method. So as a reminder, we say that the assignment method was this method that is about allocating job or task to work centers or employees. So we said the particularity with the assignment method is like one job can only be allocated to one work center or to one employee. So how do you go about doing that? This is what we'll be doing in this video. So this video is entirely about the assignment method only. The next one is going to be about the priority rules, and the final one is going to be about the Johnson rules. So for the assignment method, first of all, before starting this, we have 4 steps that you need to use to solve it. The first one is to create a zero opportunity cost table by repeatedly subtracting the lowest cost from each row and column. So I want to emphasize on the fact of row and column. So we start first of all on rows, and after the rows you go to the column. So you understand that the first part is already the first step has 2 steps. The first step is 2 parts or 2 sub steps. The first one is about the rows, the second one is the column, and the second step is about drawing the minimum number of vertical lines and horizontal lines necessary to cover all the zeros in the table. If the number of lines equal either the number of rows, then we proceed to step 4. This is if, which means that this is only when we reach the optimal table. So how do you know that the table is optimal? When the number of lines equal either the number of rows or the number of columns. So if I have 3 rows and I have 3 lines, my problem is optimal already, and I don't have to do step 3. I skip already to step 4. Otherwise you proceed to step 3. It means that like if the table is not optimal on step 2, that's when you go to step 3. So what is step 3 talking about? Step 3 is about subtracting the smallest number not covered by a line from all the other uncovered numbers, and then we add the same number to any number at the intersection. And then after that we return to step 2, which is about drawing the minimum number of lines. Then finally step 4 is about the optimal assignment at 0 location. So you select one draw line through the row and column involved. Well, I know it's too much theory, like the practical side, so let's go to a practical side. Now I got an exercise that is in the book already. As a reminder, again, we are using Operation Management Sustainability Supply Chain by Jay Hazer and Barry Render, 12th edition. Now what we are doing is exercise 15.3. So we have this company that is called the Green Cab Company that has taxi waiting at each of 4 cab stand in Evanston, Illinois. Now 4 customers have called and requested service. The distance in miles from the waiting taxi to the customers are given in the following table. Find the optimal assignment of taxi to customers so as to minimize the driving distance for customer. So the objective first of all is minimizing the driving distance. Why do you want to minimize? At the end of the day, when you minimize the driving distance, you minimize the distance between bracket, you minimize the fuel, you minimize the time, and you're minimizing cost at the end of the day. So you understand that this problem already is a minimization exercise. Now as far as this part is concerned, I want you to take note that the way you solve a minimization exercise and a maximization are a bit different. Not totally different, it's just few steps that are different. Maybe if you got time, I'm gonna solve a maximization exercise, but anyways, for now we're doing a minimization exercise. So what is happening in short is like we have this company that needs to take customers from one place to another, and we also get the stand. or taxis. So we have 4 taxis to take 4 customers, and the numbers in the table just mean, for example, the number 3 here just means that if the first taxi man need to fetch customer B, it is going to travel 3 miles. If he needs to take customer D, is gonna have to travel 8 miles. So we need to allocate one driver to one customer so that we minimize the traveling distance. How can we do that? This is how we solve. Now we are going to go back to the steps that are given already. These are the steps. So the first one is like we need to create a zero opportunity cost by repeatedly subtracting the lowest cost from each row and column. So we go back to our table here. By the way, this is the table of the exercise. So we're going to start with step 1a. Step 1a is subtract the lowest number in the row. So this is what we will do. We'll do it from the table, the original table that you already have. This is the original table, and what we will do is like we copy it and we paste it to solve 1a. We look at the rows. These are the rows from 1 to 4. We look from every row, we look for the smallest number, in this case which is 3. So you're gonna subtract 3 in all the numbers, in all the values of that row. So we have 7 minus 3, it gives us 4. Then we get 3 minus 3, which gives us 0. By the way, I'm gonna put the numbers in the table everywhere. It's only the first cell that I'm gonna put the number minus the smallest number so that you understand where they come from. So 4 minus 3 gives you 1. 8 minus 3 gives you 5. Then we do the same thing for the second row. The smallest number is 4, so we get 5 minus 4 gives you 1. 4 minus 4, it's 0. And then here you get 2 and you get 1. Then the smallest number in the cell here, it's 6. So we get 6 minus 6, which gives you 0. 7 minus 6, it's 1. 9 minus 6, it's 3. And 6 minus 6, it's 0. Then on this row here, the smallest number is 4. So we get 8 minus 4 gives us 4. 6 minus 4 gives us 2. 7 minus 4 gives us 3. And 4 minus 4 gives us 0. So we're done with the first step. It's about subtracting the lowest number in the row. So we go to step 1. We'll call it step 1b from here. So we're gonna subtract the smallest number, not in the row in this case, but in the column. So what we do is we are going to do it based on the new table that is coming from step 1a. Don't make the mistake of going back to the initial table. We're not using the initial table anymore. So we're going to use this table here. We copy it and we paste it. Now after doing that, I'm going to erase all the numbers that are here, all the values that are here, so that we can understand. So these are the values of the new table we got from step 1a. From this table here, we subtract the smallest number in the column. So we got 4 columns from column A, B, C, D, and D. Those are the 4 columns. So we look for the smallest number in every column. In this case here, the smallest number in column A is 0. So we get 4 minus 0, which gives us 4. 1 minus 0 is still 1. 0 minus 0 is still 0. And 4 minus 0 is still 4. So an advantage is like every time that you get a 0 in a column or in a row, it doesn't change because 0 doesn't have any impact. So it won't change in column A, it won't change in column B. But in column C, we don't get a 0. The smallest number is 1. So we get 1 minus 1, which gives us 0. 2 minus 1 is 1. 3 minus 1, you get 2. And 3 minus 1, you get another 2. And we go back to column D, whereby the smallest number is 0 again. 5 minus 0 is still 5. 1 minus 0 is still 0. And we get the 0. So from now, we're done with step 1a and step 1b. So we're done basically with step 1. That was about creating the zero opportunity cost lost. So after that, now we go back to step 2. That is about drawing the minimum number of the keyword here is drawing the minimum. Minimum means that if, for example, we have, assuming that we have 2 zeros that can be cancelled by one straight line, we're going to use one straight line instead of using 2 straight lines to cancel it. So what we do is like here we go back to step 2. We call it steps 2, and then use the minimum number of lines to cancel the zeros. So this is what we will do. We will do it from the table that we got from step 1b. So you understand that these exercises here, they are chains. You cannot do step 1. I mean, you use one table and you remove it. I mean, you move to another table, or you move to the initial table, sorry. So every time that you move to another table in the following step, you move with the table that you got in the previous step. Now in this case, one thing that we do is like we're gonna use the minimum number of line to cancel the number of 0. So one trick that I always use is you look at the cell or at the row that has 2 columns or more that you can easily cancel with one line. You look at this column here, this row, you realize that it has 2 zeros. So if I draw one straight horizontal line, I'm gonna cancel these 2. It likewise, I can also use one vertical line to cancel the 2 zeros on B. Likewise, I can also use one horizontal line to cancel these 2 D's here. I mean these 2 zeros in column D. Or I can still use a vertical line to cancel the zeros that are here. So at the end of the day, the only thing that I need to do, I need to cancel my zeros using the minimum number of line. So a first option might be to cancel the number of 0. Let's say we're going to cancel the number of 0 from B here, vertical line like this. So let's give it a blue shape, a blue color, and we give it like this. So we have two zeros here. So I'm using one line to cancel all the zeros. So I've canceled the first zeros. I can also decide to cancel these zeros here. They are cancelled. So I'm left with 2 zeros, 1 0 here and another 0 here. Obviously, there's no way to use one line to cancel the 2 zeros. I cannot. The line need to be horizontal and vertical only. So because I'm left with 2 zeros, I can use one line to cancel, one horizontal line to cancel this 0 here, and another horizontal line to cancel this 0. And with that in mind, my table is optimal, because I have 4 lines, 1 2 3 4. How many columns? 1 2 3 4. I also have 4 columns. How many rows do I have? 1 2 3 4 4. So I have 4 lines, 4 columns, 4 rows. Then my table is optimal. Obviously, you guys will be wondering, what if we use another allocation of line? What will it look like? Is the solution still going to be optimal? Let's try that. So you have this table here again. This is the table that we have. We're going to use other lines to cancel. So in this case, I want to use another way of canceling. Instead of canceling B here, I'm going to cancel the B's that are here. I'm sorry. So from here, you cancel like this. Yes. So I cancel this, and now I'm going to give it different colors so that purple is not nice. Okay, let me take green, and the weight, I'm gonna make it a bit bigger like this. So I've used one line to cancel these 2 zeros, and I'm still left with these zeros that are here. You know that in column 3 there are 2 zeros, this first 0 and this second. I can still use a straight line to cancel these 2 zeros, and you realize that I'm still left with 2 zeros, 1 0 in this cell and another 0 in the other cell. So what I do is, like, I can also not use the same, how do you call it, I cannot use also one line to cancel the 2. I'm obliged to use only one line. So I mean 2 lines. So what I do is, like, I can take this line here, I'm copying and paste it here to cancel this 0, but I'm gonna put it in green so that we avoid the confusion, and I cancel with the other 0 again. So whether I use the first method or the second method, I still have 4 lines, 1 2 3 4. 4 lines, 4 columns, 4 rows. My table is optimal, and there are so many allocations that you guys can do, but make sure that all the zeros are cancelled. Like, you always start by using one line to cancel as many zeros as possible. Now our table is optimal, and what is it saying? It's saying that if the number of lines equal either the number of rows or columns, then proceed to step 4. So we're not going to step 3. So what we do is, like, we skip straight to step 4. Step 3 is saying that we need to subtract the smallest number not covered. This applies if, only if, the table is not optimal. Like, if I got maybe 3 lines, but I got 4 rows and 4 columns. So we're skipping step 3. So we go straight to step 4. So now we're gonna use this. Let me take the heading of step 1. So we do like this, and then we have step 4. So step 4, what is it about? Step 4 say that the optimal assignment. So now what we do is like we assign optimal assignment. So what we do is like you assign based on the previous table again that we got. So as I told you, you always solve based on the previous table that you got. So I'm going to remove these ones and so on. So what do you do? In other words, you're going to assign the job to, or you're going to assign the job or the taxi man to the customer as a 0 only. So we're going to assign, for example, 3 here, it can only be assigned to A or, to A or D. Why? Because that is the only places where there are zeros. So the allocable part, if I can say so, is only the part whereby or cells that have zeros. Why? It means that we are making benefit, we're not making any loss. Remember, the objective is to minimize the distance. So it means that what is the allocation that we will do? You can allocate it in the 2 ways. The first way is about looking at the column. The second way is about looking at the cell. It's still the same thing. So for me, I'm going to look at the cells, at the rows. So when I look at taxi 1, taxi 1 can be allocated either to B or C. Why? Because it has 2 zeros. It cannot be allocated to A and D. So I'm going to choose B or C. This party, whenever you guys are solving it, it's better to do it without with a pencil so that you identify first, and then this is not the optimal yet. So one can go either to B or C. Then we go back to taxi 2. Taxi 2 can be allocated only to B because that is the only part where there's a 0. So 2 can only go to B because there are no other zeros. You see 1, 8, 2, 0, B and C, but this one is only 1 0, which is this one. And we go to taxi 3. Taxi 3 has 2 parts. The first part, you can either take customer A or customer B, D. So it can go either to A, or D. And finally, customer 4, taxi driver 4 can only go to D because that is the only part where there's a D, there's a 0. So you get a D here. Now, remember we said that one thing with the assignment method is like one customer, one taxi can only be allocated. One customer can only be allocated to one taxi, or one taxi to one customer. You cannot combine. So the good thing is like 2 is already allocated to B, so it's fine. 4 is already allocated to D. So we are left with A and we're left with A and B. So you realize that customer 3 cannot be allocated A or D because D is gone already to 4. So that means customer 3 can only get A. So we remove because D is already for 4. So because customer 3 can do A and D and 4 can only do D, we give D to 4 and 3 is going to be left only with A. And you realize that customer 1, a taxi 1 can do B or C, but you realize that B is gone to D, to 2. So there's no way to give 1 B. So what you can give to 1 is only C because C is the only thing that he can do and the remaining cannot do. So in that case, you allocate that 1 is going to use customer C, B is going to use 2 is going to use customer B, 3 is going to use customer A, and 4 is going to use customer D. Now we have allocated, we have 4 taxis, 1, 2, 3, 4, and we have 4 customers. Now what you do is to get the minimum traveling distance that they can do is like we go back to our initial table. We say that 1 should go to C. This is the very first table. We say that 1 should go to C, so 1 should use C. What is the traveling distance? The traveling distance is 4. So that means we allocate 1 to C, which is 4. So we can say that 1 to C here is equal to 4. That is the traveling distance. Then we go to the initial table again. 2 needs to take B here, which is another 4. So 2 is going to be allocated 4. So 2B to the optimal that we got here is equal to 4. Then 3 is going to be allocated to A. We have 3 here is going to be allocated to A, which is 6. So what we do is we give him 6. So 3a is equal to 6. 3a is equal to 6. Then we are left with 4d. We look at the table, 4 is here and d is here. It's another 4. So let's give it this color here. So 4 is 4 is going to be allocated to d, which is a 4 again. Now what you do is like, you can write something like optimal traveling distance is going to be equal to 4 plus 4 plus 6 plus 4. So we're taking these values here, 4 plus 4 for B, plus 6 for A, and plus the other 4. So after doing that, you get 4 plus 4 plus 6 plus 4, which gives you 18 miles. So it means that this guy here, this is the minimum distance that they can do. So if taxi man number 1 needs to go and take customer C, and 2 needs to take B, 3 needs to take A, this is the minimum distance that they can do. So no matter the combination that you can use, you will not find less than 18. 18 is the smallest traveling distance that these guys are going to travel. Now, so this is it about the assignment method. Obviously we use an exercise that is not using step 3. In the next video, we're going to do an exercise that's actually a similar exercise like this, but using an optimal, using a step 3. Then from there we will see what we can do. So thank you so much for your time. I really hope that this video was helpful, and see you for the next one.